Alright, so now we're finally to the fun part in this series of videos where we get to actually see how this works in the real world. So let's take a look at using the compound interest formula. I've typed the compound interest formula here for you, and I probably am going to just start off by explaining what we mean by compounding. When you go put money in a bank, the compounding is referring to how many times a year the bank actually stops and gives you interest on that money. For instance, an account could be compounded monthly, right, which is what most of them do, which means that every month they stop and they look at the amount in your balance and they give you interest based on that amount. Well, that means that if they start the whole process out, giving you interest on for the first month, then the second month, then they're giving you interest on the amount you first had in there plus interest that they gave you already. So it's a compounding, meaning it's giving you interest on interest. And so the compounding talks about how many times they're going to do that in a year. Now let me use the highlighter and let's take a look at some of these values. Let's take a look at where this compounding shows up in the formula. This N is what we're talking about with compounding. It's the number of times it's compounded in 1 year. So if they say it's compounded monthly, then that means N would be a 12. If it's compounded semi-annually, that would mean that the N is a 2. It's the number of times that it's compounded. They stop and give you money, they give you interest or whatever on your balance. That's the number of times it's compounded. So let me go ahead and highlight that. That's the yellow number. Let's take a look then at the blue number here, and that's going to be my T, and T is just the amount of time that's gone by for the loan or for the whatever, or not the loan, I'm sorry, for the that you have had the money in the account, but it has to be in years. It's not how many times a year, it's how many years. So if you've had money in an account for 3.5 years, you'd have to use 3.5. You couldn't turn it into months, is what I'm saying. Okay, so the time has to be in years. All right, and then this other thing that I'm going to highlight is the R, and the R just is the interest rate, the rate of interest that they're charging. Now, it does have to be in a decimal, not in a percent. So most of the time they're going to give you the percent symbol, right, for the percent, but we have to turn it into a decimal, okay, when we use it in a formula. All right, now, this P, this is pretty simple. The P is just the principal or the amount that's invested. So we'll call this the principal. Well, that's what it's called, the principal. The amount of money you've put in. And then A refers to the amount, the future amount. It's A because it stands for the word amount, right? And it's just the future value. How much it's going to be worth down the line, right? Okay, so let's take a look at an actual problem, and we'll plug in these numbers and use a graphing calculator. We're going to use a scientific calculator to help us find the answer. Find the amount, or that should be an or future value when a principal of $10,000 is invested at 3.5% compounded monthly for 5 years. So let's just start to list our information. That's 5. Time is 5 years. There it is. Okay, so let's highlight it. Time is 5 years. All right, let's see what the compounding is going to do, right? Compounded monthly. So that means my N is going to be a 12. That's that yellow thing. And let's take a look at what the interest rate is. The interest rate is that, but we've got to turn that into a decimal. Now remember, turning a percent into a decimal means we move the decimal 2 to the left. And so that's my R is 0.035. Okay, and that's my rate of interest. And of course the principal, right? The principal is the 10,000. And then, of course, the amount is, I don't know, right? They want to know the amount. Find the amount or the future value. So here we go. A equals. I'm going to put in the 10,000. That's my principal. I'm going to put the parentheses here. I'm going to go 1 plus 0.035. The rest of this is downhill, right? N is 12. And now, the 12 times 5 power. Now, what I typically do to get this into the calculator, I do not try to type it all in at once. I don't recommend that. What I'm going to recommend is that you take the calculator and do these few things. Take your calculator and help yourself out with the 12 times 5 if you need to. Well, that's a 60, so I'm going to make that a single number. And then I'm going to take this right here and I'm going to turn that into a single decimal. Okay, so that's what I'm going to do next. So I get 0.0029 for that. Now, think about it. If I have 1 plus that number, I'm going to do one more step, and I'm going to go ahead and write 1.0029. Now, here's what I have. I have 10,000 in parentheses 1.0029 raised to the 60th power. And that is what I'm going to put in my calculator now. Let's take a look. So I'm going to put this in the calculator. Let's take a look. 10,000 times 1.0029 to the 60th power. Here we go. We just drop it right in. 10,000 times 1.0029 raised to the 60th power. Enter. And there it is. 11897 and 56 cents. 11897. 11897.56. I don't even know if the bank would round up. I doubt it. Anyway, so that $10,000 is going to become $11,897 and approximately 56 cents. So there's some real life application. Very important to know this type of thing for financial literacy. Let's take a look at one more. And this time it's going to be compounded a different number of times in a year. So let's see how this would look. We have A equals, we have $5,000 this time. Okay, I'm going to get this ready to go. My interest rate is 0.04, so that's going to be 0.04. Now, compounded semi-annually, that would be twice a year, right? So my N is 2. Okay. Okay, again, and the T, that's 5 years, right? So that's the 5. So I'm going to go ahead and, using the formula, I'm going to go 2 times 5. 2 times 5. Now, like I said before, I don't try to put all this in the calculator at once. What I'm going to do first is I'm going to take the 2 and the 5 and make it a 10. Then I'm going to take this decimal over that whole number, 0.04 divided by 2, 0.04 divided by 2. Part of the reason that I like to write it at 0.02, so we're going to have 0.02, part of the reason I like to write it out is because I can pretty much ensure that I won't make a careless mistake because I can look over my information. Now I'm ready to put that into the calculator, and here we go. 5,000 times 1.02 raised to the 10th power. And there it is. 6,094.97. 6,094, roughly 97 cents. Instead of a 5,000, it's going to turn into 6,000. And think about it, that means that the bank has put in how much interest? $1,094.97. You haven't touched it since you put the 5,000 in there, okay? All right, I hope this is helpful. We have one more video to look at something called continuous compounding, and we'll look at that next. Thanks for watching.